Welcome to your next lecture in the series of lectures on gas laws. You are going to need a pen or pencil and paper, and you are going to need your calculator. As we go through this lecture, pause as you see necessary so that you can write concept questions or application questions or clarifying questions. Hopefully by the time we finish with this lecture, those questions will be answered, but if they are not, I strongly recommend that you address those with your instructor to make sure that you understand them before we go to the next segment. A few things, make sure also that you have your standard pressures with you, or the list of your standard pressures. Remember, your standard pressure is 1 atmosphere or 760 torr or 760 millimeters of mercury or 101.3 kilopascals or 14.7 psi or pounds per square inch. If you don't have it, write this down real quickly on your paper so that you can refer to it as we go through these problems. In addition to standard pressure, remember standard temperature is the temperature at which water freezes, and that would be 0 degrees Celsius. But we discussed how it would be difficult to multiply something by 0 and you get an answer because it's just going to be 0. It would be difficult to divide something by the standard temperature of 0 because it's undefined. So what we do is we convert degrees Celsius into Kelvin, and that is 273 K. So our standard temperature is 273 K at 0 degrees Celsius. But when we're doing our problems, we are going to be using the Kelvin to make sure that our answers are not going to be equal to 0 or undefined. Remember that if you have C, you add 273 to get Kelvin, and if you have Kelvin, you take away 273 to get degrees Celsius. One last thing, please remember that the unit for Celsius is degrees Celsius, and Kelvin does not have a degree sign. Okay? So, looking at Gay-Lussac's law, we are looking at a gas in the conditions of its temperature and its pressure. In this case, the volume of the gas is going to stay constant. Below, you see the formula for Gay-Lussac. And with Gay-Lussac, we have two ratios equal to each other in value. So we're going to have to once again cross multiply. So we get P1 T2 is equal to P2 T1. That's your linear, and I would write that down. If you have difficulty figuring out how those work, you can write that down, so that will help you out. And then while we're going to multiply the pressure and temperature of one condition and divide it by the change in pressure to get what the temperature of the other condition was, or we're going to divide it by the change in temperature to find out what the pressure of the other condition is. The biggest thing with this, of course, is to make sure when you are calculating these problems, you remember to convert to Kelvin to do your math, okay? Your responsibility, of course, is to make sure that you know the formula for Gay-Lussac and make sure you know that formula goes with Gay-Lussac, and that's his formula. Okay, so looking at temperature and pressure, if the ratio or the relationship is pressure over temperature, that tells me then that pressure is equal to temperature. And that tells me that temperature and pressure are directly proportional to each other. Make sure you understand directly proportional. That means that if my pressure goes up, then my temperature is going to go up. If my pressure goes up by a factor of 2, my temperature is going to go up by a factor of 2. They are directly proportional to each other. So an increase in temperature means my pressure is increased, and an decrease in temperature means that my pressure has decreased, because they are related to each other. It is Boyle's law, where pressure and volume are indirectly or inversely proportional to each other. But in Charles' law, volume and temperature are directly proportional, and here in Gay-Lussac's law, pressure and temperature are directly proportional to each other. Okay, so once again, make sure that you know the formula for Gay-Lussac's law, and make sure that you know that that formula is a Gay-Lussac law. Okay? All right, so let's do a problem. We are going to be working in Kelvin, of course, and reporting in degrees Celsius. We have to work in Kelvin. Please remember that. So, given a sample of gas at 20 degrees Celsius and 600 kilopascals, find the temperature required to make the pressure 800 kilopascals without changing the volume. So here we have our first condition, temperature 1, and our pressure in condition 1. We do not know our temperature for condition 2, but we do know that our pressure for condition 2 is 800 kilopascals. So we'd have to set up our equation just like we normally would set up the equation based on the formula. But before we can do that, we have to make sure that our temperature is a workable temperature. So if you look at T1, T1 says that we have 20 degrees Celsius. We're going to need to add 273 to get what Kelvin is, which is 293 K. Now we're ready to plug and chug, and that's all. It's a simple plug and chug. Once we plugged it in, we are going to then cross multiply, and that is going to give us 800 times 293, which is going to be equal to temperature, the new temperature, times 600. We need to divide both sides by 600 to get rid of that 600. Clear your calculator. Open parentheses, 800 times 293, close parentheses, divided by 600. That is going to give us our T2, which is T2. Give me a second. I got to do this with you. So 293 times 800 divided by 600 is going to give us, what is that, 390.6, which can be 391K. But am I done with that? Well, let's look. I gave you degrees Celsius. You've calculated it in K. So that is not going to work. I have to make that go back to my degrees Celsius. So I'm going to subtract 273 from that, and that is going to give me 117.7, and again, it's degree Celsius. If you got that correct, excellent. If you didn't get that correct, then go back and redo the problem. So, why did I put 118 degrees? Because this can be rounded to 118 degrees. Okay? It can be rounded. But make sure that your units match the units that I want. Pause the video if you need to. Rewind the video if you need to. Otherwise, we'll continue on. A sample gas at 20 degrees Celsius and 18 psi. Find the temperature required to make the pressure 8 psi without changing the volume. Here I have T1. I have P1, remember that's PSI. Here I don't know what T2 is, but I do have P2. So I now just need to fix my temperature, which is 20 degrees. I'm going to add 273. That's going to be equal to 293. And remember, it's K because I've converted it from degrees Celsius to K. Then I'm going to do the plug and chug. Just plug it in. Then I'm going to do my cross multiplication. And my cross multiplication is going to be 293 times 8 is equal to 18 times my new temperature. I'm going to divide both sides by 18 to get rid of the 18. Open my parentheses. 293 times 8, close parentheses, divided by 18. And once you press the equal sign, you should get 130 for your temperature if you round it. But this is, remember, in K. So I'm going to have to subtract 273 in order to get my degrees Celsius. So go ahead and do that subtraction. And once you do that, your answer should be a negative 142.8 degrees Celsius, which of course will round to a negative 143 degrees Celsius. I gave you degrees Celsius. You give me back degrees Celsius. Remember that degrees Celsius can go as low as a negative 273 degrees Celsius, but it cannot go any further. Okay? All right. Your turn. Here you have a sample of gas at 90 degrees Celsius and 3 atmospheres. Find the temperature required to make the pressure 5 atmospheres without changing the volume. Go ahead and pause the video. Do the problem in its entirety. Remember to convert it back to degrees Celsius. And then check and see if your answer is correct. Okay, so here you have to set up. Do your cross multiplication. And with your cross multiplication, you are going to have 363 times 5 is equal to 3 times T2. Divide both sides by 3 to cancel them out. Press your equal sign, and that is going to give you 605. While you remember that that is actually K, so you have to subtract 273 from that, and that is going to give you a degree Celsius, and in this case your degree Celsius is going to be 332 degrees Celsius as your answer. Again, I gave it to you in degrees Celsius, you give me back degrees Celsius. If you got that correct, absolutely wonderful. If you're still having a little bit of difficulty, I would go back through this lecture once again. If it's still not answering that question, you haven't missed anything, then make sure you address that with your instructor as soon as possible. Thus ends this lecture. Have a good day.